What's up, math scholars? Hopefully you're having a happy Monday. You know what makes me happy? We have a 4-day weekend and only a 4-day week. Hopefully you're excited to learn about 5.5 day 1. Let's give a shout out to Kylie. Hope you get better soon, Kylie. Yeah! Woo! So we're going to start with adding and subtracting fractions. So this is just a real quick recap on how adding and subtracting fractions work. You need to worry about common denominators. Now when you multiply and divide fractions, common denominators aren't a thing. But when you add and subtract, you want to make sure your denominators match. And then when you go to actually do your adding, you add the top, but you keep that bottom the same exact number. Same with subtracting. You make sure your denominators match. You subtract the top, just keep that denominator the same. So we'll start with like a 3rd grade problem. What is 1/3 plus 5/3? Awesome. So you guys remember, you add the top, but you keep the bottom of 3. You don't want to add the bottom. Okay? That was your 3rd grade problem. Now we're going to do your high school problem. So I'll scroll it a little bit. Here's your high school problems. Well, here's the first one. So you ask yourself, do my denominators match? Yes, so we're ready to rock. What is 3x plus 7? Can you make that a 10x? No, you cannot. So you just write it 3x plus 7. And then the bottom is a what? 5x squared. So don't accidentally make that a 10 or 25 or anything crazy. Just keep it the same as it is. This will not cancel at all. Even if I try to factor the bottom a little bit, the top is not factorable, so you're done. Okay, here's a subtraction problem. Do our denominators match right now? Yay! So we're going to go ahead and subtract off the top. Are you allowed to subtract a 9x cubed and an x squared? Can I make it like 8x cubed or anything? No, because one's an x cubed, one's an x squared, and if they have different exponents, they're unlike terms. And then my bottom is an x plus 1. Now the top actually is factorable. Don't write this down though, okay? If you factor an x squared at the top, you're left with a 9x minus 1, and that really doesn't help your canceling, because you need these to match exactly. So I can attempt to factor, but it doesn't do anything as far as helping me simplify. So don't waste your time. The bottoms are actually going to be the same all day today. Tomorrow the bottoms will not be the same. So go ahead and try this one all by yourself and try to simplify it all by yourself. All right, hopefully you got 5 over 2x after you simplified. All right, try one more by yourself, and then we'll go on to a different topic. So I'm going to pause the video, and you can try it by yourself. So hopefully that went well. 1 over 6x. Raise your hand if you got it all by yourself. Okay, so we're going to move on to something called a least common multiple. We will be using least common multiples tomorrow to help us get common denominators. But for today, we're just going to learn about how to find them. So I'll click pause, and maybe you can click pause as well while you're watching this video to take notes, but it's going to talk you through the 2 steps. You'll be factoring each polynomial, writing numerical factors as products of primes, which you might be wondering what I mean by that. If you have the number 24, you're going to want to make yourself a factor tree, either in your head or on your paper. 24 is 8 times 3. 8 is 4 times 2, and 4 is 2 times 2. And then you're going to want to write it as a product of prime numbers. So since I've got 3 2's, I'd write it as 2 to the cubed. And then I have 1 3, so I'd write it like that. That's how I'd write any numerical factor. And then when you're done, you'll write each factor to the highest power it occurs in either polynomial. I'll hit pause. Okay, so it's going to be our job. We're going to be given two polynomials, and it will be our job to find the least common multiple between them. Now, tomorrow, these guys will be our denominators, and our least common multiple will be the common denominator that we'll be using. So that's where this is leading to. All right, so we just start with step one, which, if you had written down, it was factor each polynomial. So how can I factor my first polynomial, my 5x cubed? I can't really. So if you want to do anything, write it as 5 times x cubed. So you realize those are two separate things coming together with this product. Okay. How do you want to factor your second polynomial? Bring out a 5 and bring out an x. I'm just going to write it as 5 times x, so you're aware those are two separate things. That would leave me with a 2x minus 3 on the inside. So that finishes off step one. Everything is factored. Here is where it gets weird. The step two is weird. I did the whole entire thing. So this is like a polynomial, this whole entire thing, and I factor it. You okay with that? Okay, so now this is where it gets weird. I'm going to read you the step. Write each factor to the highest power that it occurs in either polynomial. I call this my check mark step. So what I'll do is I'll find a 5 and I'll check it, and I'll find a 5 and I'll check it, and I put it on my list to the highest power it occurs in either polynomial. So since it was 5 to the first here, and it was 5 to the first here, it goes on my list as 5 to the first. Now pretend this was 5 squared, then it would go on my list as 5 squared.
Okay. Are you writing anything between that and that?
No.
Would the other one need to be 5 squared then?
If either one of these was 5 squared would go on my list. Because you put it on your list to the highest power it occurs in either polynomial. All right, let's try our x's. So we have the factor of x here. We have the factor of x here. We want to put it on our list to the highest power it occurs. So it's going to go on our list as x cubed. Does that make sense? And the only other factor that has not been included on your list, because you need to include every single factor on your list, is this factor. It's like a big factor. This is the factor 2x minus 3. That'll go on my list as a group in parentheses. And that's it. So tomorrow, this would be the common denominator I would use if these two were the denominators of my fraction. But for today, we're just going to learn how to list out the LCM. We're going to actually do common denominators. Yep. All right, we're going to do two more. We're going to find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. So let's start with factoring our first polynomial. What would you guys do to start this one? Take a 4 out. Love that idea. 4 times x squared minus 4. Now we're definitely still not done. We need to write that 4 as a numerical product of primes. So it has to be like 2 times 2, in other words, or 2 squared. So 2 squared is how you have to write the 4. Can the x squared minus 4 factor down any further? Awesome. Lexi recognized this of the difference of perfect squares. Positive 2 and negative 2 will multiply to negative 4 and add up to 0. So now we're done with that first one. Awesome job. So the better you are at factoring, the better you'll be at finding all these common multiples. Least common multiple. And that's the same thing as common denominator. What do you guys want to do to start out the second one? Take a 6 out. Love that idea. And I really love it because now it'll be an old-fashioned factor technique. The 6 is gone. Negative 24 divided by 6 is negative 4. And 24 divided by 6 is positive 4. I would want to write the 6 as 2 times 3. 2 to the first times 3 to the first. And then how can I factor this even further? X minus 2 and x minus 2. Since you said x minus 2 twice, are you okay with me writing it like this? X minus 2 squared. And that's how they would want you to write it. Okay, we're ready to do our check mark thing. Now keep in mind, you're only looking here, and you're only looking here, because that was our overall answer when we factored it. So let's start with our 2. I see a 2 on my list here, and I see a 2 on my list here. And when I go down for my least common multiple, I want to put it to the highest exponent it occurs. So it would be 2 squared. All right, I see a 3 on my list here. I don't see a 3 on my list here, but it still needs to go on the list, because everybody needs to be on the list. So 3. I see an x minus 2 squared here, and I see an x minus 2 here. So what would it look like on my list? Awesome. Because you put it on your list to the highest exponent it occurs. And then my only last one that doesn't have a check mark is that one, so it's the x plus 2. Isn't that a huge, huge, huge thing? That would be the common denominator you would have to use if these 2 polynomials were your denominator and you were adding fractions. Crazy. We'll do one more problem. Is there questions on this, though? This is a weird, weird, weird concept, and it's unlike anything you've seen this year, so it's kind of hard for me to teach it to you. It's so different. Questions before we do our last one? You want to try the last one all by yourself, or not quite ready for that? By yourself? Okay. All right. We'll officially call it the graduate question. I'll pause the video and give you some time. Okay. What you see in pink is how I would factor down my 8x minus 16. I did write my 8 as 2 cubed. And what you see in blue here is how I factored down the other polynomial. I did rewrite the 12 as 2 squared times 3. To get that, I did a little factor tree over on my other board. So it's 4 times 3, and then 2 times 2 times 3. You have to be all the way down to your primes. This is my favorite part. We get to do our check marks. So I've got a 2 cubed, I've got a 2 squared. So I'm going to put a 2 on my list, but what power should I put him to? The 3, because you want the highest exponent that appears on either list. Okay. I've got a 3 here. I don't have any 3 here, but it does need to go on the list. Everybody needs to be on the list. I've got an x minus 2 here and an x minus 2 here. How would he look on the list? It's just an x minus 2. It's technically to the first power because it was technically to the first power both of these places. You don't write the first power though. So the last thing not on our list is our x plus 3. It does need to go on your list. So that's done. That's your least common multiple. That would be your common denominator tomorrow. Question?
Imagine what order you have, because
So here is the homework. It's on the book. Hopefully you had a fun day.